Hey! Hi! Hello there! How are you? I wasn't planning on making this video at all. I actually had no intentions of making a video like this until I was sitting here bored and decided, well, maybe it's not a terrible idea. So, yeah, here we are. Alright, so this is kind of the pre-launch video. This may be a portion of the launch video. You may have already seen the launch. This might be a video that goes up after, just talking about the rocket, or it'll go up before. I honestly have no idea. You may never see this, so there is that too. I just got a shipment in of some components to actually make this rocket finally fly, and I 3D printed some things to make the rocket fly. Because the last video you saw, I just was holding a printed rocket with nothing to make it fly. So now I have a little bit more stuff. The only thing I'm missing is the motors, so that's why we haven't launched yet. But today we're going to go through some of the stuff I've been printing, along with some of the stuff I got, and kind of just talk about the final iterations of RP. Now, I really couldn't come up with a name for this rocket. Because it's a prototype, I didn't think it deserved a real legit name. So its name is just RP, which literally just stands for Rocket Prototype, or since the channel is Rockomax32, maybe it's Rockomax Prototype, I don't know. Falcon 9, SpaceX's Falcon 9, runs on RP-1 for rocket fuel and liquid oxygen, or LOX. So maybe, I was considering calling it RP-1 because it's Rocket Prototype 1. I might have rocket prototypes in the future, so it makes sense to have RP-1, Rocket Prototype 1, and it has the same name as the rocket fuel SpaceX uses. I'm not sure. I never went with it. I don't know. It's a prototype rocket. Why does it need a name? So it's RP. You can call it RP-1. If we make another prototype rocket in the future, this will definitely be renamed to RP-1. But for now, it's RP. Actually, I kind of just like RP-1 now. Okay, this is RP-1. Ignore everything I've said so far. Alright, so this is the main body of RP-1. And we also have the nose cone here. These are the pieces that I previously printed. They were sitting on a shelf forever. I've just had this, and now I'm finally deciding to build it into a functioning rocket instead of just a printed prototype. So I went over this structure in my previous video, or actually 2 videos ago. I went over this whole rocket, so I'm not really going to go through it again. All I'm going to say is the main body is a 4-piece design. 4 pieces were printed, and it's been assembled into this using a form of packing tape to seal off all of the holes and hold it together. And we have the nose cone, which is a 5th printed piece, which goes on top. It is not held on besides with friction, and an ejection charge will cause pressure in here to fire it off, and a parachute will subsequently bring RP-1 back down to the ground. So we're not going to talk about the actual rocket prototype much more because we've already gone over that. We're going to talk about some of the other printed parts off to the side of me and the overall strategy for launching this rocket. Alright, so first thing up is this little thing right here. This is just a little adapter because, as I think I talked about in the last video, this rocket was just designed with a big open hole at the bottom. So this is an adapter to go from this large diameter to the actual diameter of the E-class rocket motor we're going to be firing it with. So that goes in there, it locks in. We could even screw it in from the outside into that inner plug, but instead, it's just simply getting friction fitted. For the first launch, it's just going to be friction fitted in with the motor in. It's going to be kind of tapped in to make sure it's really in there, and we're going to launch. If in the future we realize that some screws to hold it in are necessary, we will do that. But for now, it's just a simple printed. By the way, all of this is made out of PLA. I don't think I clarified that in my last video. Everything I'm showing you is made out of PLA. PLA is just the simpler hyphenated name for polylactic acid, which is the most common type of 3D printing plastic. It has a relatively low glass crystallization temperature, meaning low melting point, and also it deforms at a very low temperature. So, versus other plastics. Obviously, it still has to be 190 degrees Celsius to melt, but compared to other plastics, that's pretty low. And compared to the heat that can be outputted by these rocket engines, that's also pretty low. So the rocket has been designed in such a way that the motor should not contact the plastic anywhere, and if it does, it's somewhere where it won't contact it long enough to actually force the plastic to reach that glass crystallization temperature and start deforming. But anyways, we have this small coupler which will go it next down from the larger diameter to the engine diameter. So this is the first piece we printed. I printed that a few days after the last video because it is a necessary component for this rocket to fly. Next up, continuing with the trend of rocket motors, I had the idea of wanting to do a static fire of one of these motors. So these pieces right here, printed in red PLA, actually AIO Robotics PLA, I did a review of some of their filament in an earlier video on this channel. It's one piece that has been mirrored, so it was the same file. I made the file once, printed it, and then just printed another one. Each piece took about an hour and a half, so all combined, 3 hours of printing. We have two pieces which are designed like this, so you can see a small curve, which is the diameter, or actually the radius, because it's only half, of one of the E-class rocket motors, which is 24 millimeters. So with two of these together, we can put some screws between them and mount this to a test bed where we can do a static fire test, because it creates that full circle. It clamps down on a motor and will hold it in a stationary position just to see how much thrust they output, get some specs before we even fly. The motors, the E-class rocket motors, we're flying with E12s. They come in packs of 3, so I started to think about it. I think I would rather get 3 launches out of RP-1 rather than 2 launches and a static fire. So while the first video with all of this was going to be a static fire, which I was going to perform the day that I get the motors, I was going to clamp it up and go ahead and perform that static fire test, I don't think I'm going to be doing that anymore. I do have the pieces now, so if I want to do a static fire, I have mounting hardware to do it, but as of right now, I'm not planning on doing a static fire test. We're just planning on launching this thing on rocket motors that we know nothing about. What could possibly go wrong? Alright, next up actually involves the launch pad, so let's grab that. This right here is falling off my table and is the launch pad. It has a long launch rod right in the middle of the pad. So if we take it apart and actually set this rod down, you can see that it's simply an aluminum, actually I think it's steel. It's probably steel. We have a steel blast pad, which has obviously seen flight before because of all of the charring on it. This was with those smaller power rockets that I was talking about having been the only things I've flown. Then we have a plastic launch base. This is a starter kit. It's not really meant to launch higher power rockets, so I will probably have to build a launch pad in the future, but I'm planning on first trying to just optimize the one I have. So this metal plate locks into our plastic, and then we could just launch straight from this, or you have your launch pole, which inserts into the middle and creates a launch trajectory stabilizer, basically. So the rocket, using a launch lug connected to it, which goes around this, it forces it to go straight up. So I realized if I wanted to utilize this on RP-1, because it has no launch lugs built in, I would need some launch lugs. Now that is exactly what these things are for. So these are launch lugs. I have charred dust all over my table now from that launch pad. Yuck. So first was my first design, a super tiny little thing that you can probably barely see. It's basically a cylinder with another cylinder and a hole in the middle. Terrible design. It would technically work, but it's awful. It absolutely sucks. This piece right here is trash. I don't know what past me was thinking. Get out of here. So I upgraded to this design. Much larger, does the job much better, and after designing this, I tested it out, test fitted it on the side of the rocket. It fits very well. I could just as easily put it down here on the base as right up here. And it's a launch lug, so it contours to the side of the vehicle and then has a hole in it which will run up the actual line of the launch pad, or the pole of the launch pad, and will force the rocket in a straight up. This is extra weight, it's aerodynamic, it's an aerodynamic impedance that is only on one side. I designed it to try and be as aerodynamic as a protruding thing from the side of a rocket can be, but at the same time, as you can see, it's just going to be there. I tried to make it aerodynamic, but it will always ultimately be less aerodynamic than just having the rocket without it. So whether or not the rocket will fly with this, I'm not sure. I think I'm going to start it with this just because it's kind of a fail-safe. It's just a safekeeping kind of thing to have one of these launch lug installed. But at the same time, I would love to get to a point where the rocket doesn't need it. Now, then you start talking about requiring TVC or thrust vector control and computer hardware and whatnot. I vowed to not put computer hardware into a prototype rocket, because we are really just testing engines and parachutes and the concept of an assembled rocket made out of multiple 3D printed parts. So I'm not planning on putting any electronics in this rocket. So this launch lug may be pretty necessary, but at the same time I don't really want to use it. So I'm not sure if I will. If you really want the files for this, spam my comment section and I'll put it up on Thingiverse so that you can download it. It's very simple. You could probably make one yourself, but if you really want mine, just spam me in the comments below and beg for it, and maybe I'll give it to you. We have these, which are launch posts, launch towers. Don't really know how to describe them, but they're simple rectangular prisms that are all 3D printed out of PLA. They have a small groove in the top. I don't know if you can see that, but a small groove in the top where each of the fins fits in. Just kind of notches in there like that. So, with a setup of 4 of them, all angled in, we can set up the rocket to be standing on them, which gives us a little bit of clearance to get our igniter up in there, just to get it off of the pad and overall prep the rocket for launch. So, a lot of kit rockets just simply have fins that extend further down than the body or the airframe of the vehicle. It's very hard to 3D print something like that, because obviously the middle section will just be completely suspended in the air when you're trying to print it upwards. So that was not possible. So instead, it just made a lot more sense to create launch mounts, just to create launch mounts for the rocket to stand on. So hopefully in the future we could have some form of metal or wooden launch pad that these little launch lugs are screwed into to force them to stay there in a position that the rocket can notch into, and without this pole, without the launch lugs or anything, it'll just be standing just like this and lift off from the pad. So, while that does mean designing our own launch pad in the future, which will probably end up happening, these are a very versatile thing right now. They could be launched in our next rocket as long as it has fins. This rocket, even smaller rockets, they're very versatile, because they can be positioned anywhere, like absolutely massive rockets or super tiny rockets. So super versatile in that way, and they don't have to be screwed into something. The way that RP-1 will be launched will be on this pad with the guide pole, or possibly without, with this metal plate for blast shielding, and it will simply utilize these 4 launch posts or launch mounts to hold the rocket. As you can see, the rocket is on the pad, on the blast proofing metal, but at the same time it is on these launch lugs and it is ready for launch. So without the post, it would be squared up in the center and just simply launch from here. Because these launch mounts would not be screwed into this metal plate, the first few launches when RP-1 doesn't have its own launch pad, it's just launching from this, I already know that the rocket fuel being ejected downwards will hit this plate, kind of go everywhere, and blast these off to the side. So these may be expendable. After one launch, I may never see these again and have to print more. But that's the beautiful thing about 3D printing, was each of these took 45 minutes to print and just a little bit of plastic. And 45 minutes later, 4 times, I have 4 of these ready for launch. So yeah, RP-1's research and development has so far brought us to this point where we are officially ready for our first launch. Besides not having the rocket motors, we are completely ready to fly. All of these parts have been printed. Launch lugs to mounts and clamps to motor adapters, even possibly static fire mounts. We are ready for launch. I also recatted the nose cone. So I said I wasn't going to redesign any of this rocket because it had plenty of flaws, and in the end, it's a prototype rocket. Once we've learned what we can from it, we're moving on. So why redesign all of these pieces based on how I designed them the first time when they're flawed and I hope to move on from them in the future? Well, I did redesign or recad or basically measure every single piece of this nose cone so I could remake it exactly the same, because to the rocket body, and that's it. So when the ejection charge goes off, it's going to fire off the nose cone. The nose cone is going to go shooting away and fall down somewhere in the field. The parachute will also get ejected, open up, bring RP-1's rocket body down to the ground safely. This is going to go flying. Depending on how high we get, that could prove fatal for this piece, and we may never see it again because it just flies too far away, we can't find it. We may find it and it'll be absolutely destroyed, and we'll need to print a new one. So I did redesign this while I still have it in my hands. I could get every measurement I need, but I am hoping that we can just simply watch where it goes and recover it, so that in the future we can just simply put the same one back on and RP-1 will be ready to fly in the exact same configuration. Now the next part is the parachute system I've been talking about, which is all of this nylon, right there. Okay, it's falling off my table. Some high-strength orange nylon and a very nice parachute for our recovery system. Now you'll see that this nylon is marked for where it needs to be cut for this rocket, because we do not need 10 feet of nylon recovery band for a 2.5 foot tall rocket. No, that's just not how that works. So this will be cut. It's been marked, but it hasn't been cut yet. Also, obviously, it hasn't been mounted in the vehicle yet. Also, while I've been holding it attached to the parachute, it's not actually attached to the parachute yet, so that's just me holding it. So these were all purchased from Apogee Components. They're not sponsoring this video, but it's a great website for model rockets. Obviously, I didn't buy any body tubes or any motor mounts or anything from them because I printed all of that. That's one of the great things, once again, about 3D printing your whole rocket. It's just, from the ground up, yours. You're not modifying something that you purchased. But for recovery stuff, I can't 3D print a parachute yet, so Elon, hit me up whenever you figure out how to do that. It's made by Dino Shoots. That's the company. It has a little dinosaur here. And it's a 24-inch X-form chute, meaning that actually when it's laid out, it's in the shape of an X, so it's not a full circle. You'll see that it makes an X or a cross, but whenever the strings are pulled, it creates that parachute shape, which will bring our rocket down, obviously. So we can't just simply tie the inside of this to the rocket because it's a ton of strands. So instead we get this, which will support the rocket even lower down from these strings. So this will simply go through here, link up, be nice and sturdy. All of this is super strong, made out of nylon, super tough stuff, and coast us down to the ground safely, hopefully. So while I could reroute this to not only connect to the rocket body but also the nose cone, it's a waste of time for me. When I can just print one of these nose cones in an hour and a half, why would I waste the time trying to recover this nose cone? It's one of those pieces that, like, SpaceX launches their Falcon 9, they have to expend the second stage booster. While they could probably save it, it's a waste of time and money for them to even try. For me, it's a waste of time for me to even try to rig up the parachute to try and save this. While it's totally possible, I would rather just use this 24-inch parachute to ensure that RP-1 will make it down to the ground, and maybe I'll have to print a new nose cone. But this is a very nice parachute, actually super nice. After its missions on RP-1 are complete, this parachute may go on to my next rocket, which has already been fully designed. It is sitting in CAD, ready to launch. It will have the capability to fly with 2 E12 rocket motors, which this is running on 1 E12 rocket motor, so it may have 2 at the bottom. It will have the capability to run on an F-class rocket motor, not 2, just 1. This rocket may fly on Fs in the future, but I'm not holding out a ton of hope that it will, because it's just a prototype. But then my next generation rocket, the first iteration of the True Rocket program, is fully designed from the ground up to be a superior version of RP-1, and will be much more powerful and fly much higher. Might even do 2-stage F-class rocket motors in the future. Not positive on that, but we might be able to make it work. But for all I know, after RP-1's mission is complete, instead of having to buy a new parachute, this Dino Chute might just move on to my next rocket, which already has a name, which I almost just said the name, but I'm not going to reveal the name just yet, because I want you to come back for that. parachute deployment test number 2 in 3, 2, 1. This is not turning into a model rocket channel. Still going to be plenty of car content, plenty of me screwing around with my friends, maybe some Lego City stuff, not doing as much of that. Definitely 3D printing stuff. This is really going on the channel because it's 3D printing. I do love rockets, but it's on the channel because it's 3D printing, not because it's rockets. It's just really cool that it's rockets. But yeah, and also since the channel at the end of the day really is a vlog, I'm vlogging my life creating a rocket. So I hope you enjoyed this video. I hope that it gets you psyched for the launch of this vehicle. I'm going to make the beginning of the video just rocket launch. It's just going to be footage, none of me talking, just the rocket launch. Then we will come back for a post-launch analysis where I will tell you what happened and we'll go through all of that. Very much like BPS Space does it. If you haven't seen any of his videos, check it out. He doesn't print rockets, he prints components that he might need. So he still uses 3D printing very practically for model rockets. So if you haven't seen that, go check that out. Working with computer systems and thrust vector control, along with he has his level 2 certification for model rockets, or for high power rockets. So really cool channel. A lot of what inspired me to make RP-1 fly. But anyways, thank you guys so much for watching. I really hope you enjoyed this video. I know that it's kind of not the normal content, but I hope you're enjoying it. I hope you're as stoked for the launch as I am. Mustang mods coming soon. I know I'm constantly saying this, but I'm actually starting on planning to order some. So get ready for that. Not exactly sure when that content's going to come, but hopefully soon. Like I said, I hope you're stoked for this. Subscribe. Our current subscriber goal is 1,000 subscribers, so please help us get to that goal. It's free to subscribe, and it only helps the channel, so please do that, and I thank you for doing that. That's it from me. Smash a like and comment down below that you're excited for this, and just that you're excited for the whole program. Also, just if you enjoy the channel, smack a like on the video. Thank you guys so much for watching, and I will see you in my next video. Peace!